Welcome geometry students to the homework help video, page 286, 8 through 16, 21 through 26. Please have your homework out, please have your books out, your pens, pencils, calculators, whatever it is that you need. Let's go ahead and get started. Numbers 8, 9, and 10, they all have the same directions, and the directions state, determine whether the figure in red is a reflection of the figure in blue. Explain why or why not. Okay, let's take a look at number 8 here. What I've taught you today in class is if you were to fold this sheet of paper over hold on one second please. There you go. If you were to fold this sheet of paper over on this line right here, would this blue moon-shaped object fall right on top of this one over here? And the answer is yes, it would, definitely. This point here would correspond with this point here with this point here, and this curve right here would fall right on top of this curve here, and this curve right here would fall right here. So yes, and then the directions say to explain why. Well, it's very simple. It's just a reflection. I mean, it's like looking in a mirror. The red figure is a reflection of the blue figure. I just don't know how else to say it. I mean, it is what it is. By definition, it's a reflection. Okay, let's take a look at number 9. Now, if you were to fold this sheet of paper in half on this black line right here, think about it. And if you need to draw these on a sheet of paper and fold the sheet of paper over, like put your piece of paper over top of this and trace it out of your book and then fold it over, please feel free to. Nothing wrong with that. But if you were to fold this gray, pretend this is a gray sheet of paper and fold it right here, this point right here would land on this point here. This point right here would land on this point, this line would fall on this line, and this circle would fall on this circle. So yes, that is definitely a reflection. Number 10. Now this one is not. This one is not. Now watch, if I had a gray sheet of paper and I folded the gray sheet of paper right on this black line. Now the bottom part would not be fine either, because what would happen is this point right here would end up coming way over here, and this point here would end up coming over here, and this point here it looks like would land right here, and this point here would land right here, and then what you have is an object that looked like this. That's incorrect, sorry about that. An object that would look like this, and that would come up like this, like that. Okay, it would not fall, and actually that's incorrect, and I apologize guys, I'm not a perfect teacher. That's not what it would look like. It would look like this. It would come up and let's see, it would look like this and like that, just like that. Okay, if you were to fold that over. So no, this red figure right here is not a reflection of the blue figure over here. It is not. Okay, pretty easy stuff. I don't think it's that hard. It's just kind of looking and figuring and trying to figure things out. All right, numbers 11, 12, and 13 all have the same directions. Tell whether the grid shows a reflection in the x-axis or in the y-axis or neither. Okay, well here we go. Let's take a look at number 11. It looks like to me we would have a perfect reflection if we folded it right on the y-axis. In fact, we would. If we were to fold this sheet of paper right on the y-axis, then red would be a reflection of B. So we would say for number 11 that we have a reflection in the y-axis. We have a reflection in the y-axis. Number 12. Well, students, listen, I'm telling you right now, if we were to fold this sheet of paper right on the x-axis, this blue triangle would end up down here somewhere. And if we were to fold this paper on the y-axis, this blue triangle would end up over here somewhere. So no. Now what you're going to learn later, by the way, and no, that's not true. I was getting ready to say we had reflection with respect to the origin, but we don't even have that, and don't worry about that. That's for later on. So no, this red triangle is not a reflection in the x-axis or in the y-axis, either one. So the answer is neither. Neither. We do not have a reflection in the x-axis, and we do not have a reflection in the y-axis. Now here, think about it. If we were to fold this sheet of paper right on the x-axis, this point here would fall here, this point would fall here, this point would fall way over here, and this point here. So yes, we definitely have a reflection, and we say it would be in the x-axis. Reflection in the x-axis. I hope that makes sense, guys. Rewind these videos as often as you need to until you understand what's going on. All right, number 14. Let me get a drink of water here real quick. Okay, number 14. The directions state for 14, 15, and 16. Use the diagram at the right, or use this diagram right here I've drawn for you. Number 14 says, you can follow along in your book. Excuse me for yawning. Number 14 says, which segment is the reflection of AB in the x-axis? So here's AB, here's the x-axis. If we were to fold this piece of paper right on this line right here, GH would be the reflection of AB in the x-axis. So the answer to the first part of 14 is segment GH. Segment GH is a reflection of segment AB in the x-axis. In the x-axis. All right. Let's take a look at the rest of number 14. Which point corresponds to A and to B? Well, point G corresponds with A, however you want to write that off to the side, and point H corresponds with point B. So however you want to write that in your homework, be sure and write that down. Okay, question 15 says, which segment is the reflection of AB in the y-axis? So here's AB, here's the y-axis right here. If I were to fold this sheet of paper right on the y-axis, this blue line here would fall right on top of this red line right over here, this red line. So I'm going to say that segment DC is a reflection of AB in the y-axis. Segment CD is a reflection of segment AB in the y-axis. And then the question says, which point corresponds to A? Well, however you want to write this in your homework is up to you, but A and C would correspond. They would fall on top of each other, and B corresponds with D, or D corresponds with B, however you want to say that. Okay, so that's the answer to the rest of number 15. I never skipped ahead number 15, did I? Sorry, there's 15, and now here's 16 right here. Now 16 says this: compare the coordinates for AB with the coordinates for its reflection in the x-axis. How are the coordinates alike? How are they different? Okay, so watch what I do. Please, students, watch this carefully. The coordinates for A right here, I'm going to go to a different color. The coordinates for A would be -3, 1, right? We're over 3, and we're up 1. So -3, +1. Now B is over 1 and up 3. So the coordinates for B would be -1, 3. -1, 3. Now, what's the coordinates for G? Because if you look at 15 or look at 16, if you look at number 16 again, it says, how are the coordinates for AB with the coordinates for its reflection in the x-axis? So in other words, if I were to find the reflection of AB in the x-axis, that means fold the paper here, what segment would I be talking about? Well, obviously this segment right here. So now I'm going to find the coordinates for this segment, and we're just going to compare them. That's all we're going to do. So this segment here, we're over 3 and we're down 1. So it's going to be -3, -1. -3, -1. And this point right here would be -1 and then down. And actually, guys, I just counted wrong. I'm sorry. Would you go back to point B here real quick? It's over 1 and up 4, wasn't it? Sorry about that. It's over 1 and up 4. 1, 2, 3, 4. So this would be 1, 4. Very sorry. Get out your erasers and fix that. Now, this would be -1 and then down 4. So this ordered pair right here for H would be -1, -4. Now they want us to simply compare the points and look for similarities and look for differences. Well, I can see it already. Compare this point right here with this point here. Notice the x-axes are the same and the y or the x coordinates or the x numbers are the same, -1, -1, and the y coordinates, the y numbers are what we call what of each other? Opposite. Remember we learned in algebra, opposite means you simply change the sign. So the x coordinates stay the same and the y coordinates are opposite. Their signs are different. And look, the same thing happens here with these two ordered pairs. Notice the x coordinate is -3 and the x coordinate right here is -3. So the x coordinates are the same, but the y coordinates are opposites. One of the y coordinates is a 1 and one of the y coordinates is a -1. And so how would I word this answer? I would say the x coordinates stay the same and the y coordinates are opposite of each other. All right, that's what I would say. There we go. All right. Okay, moving on to numbers 21, 22, and 23. Decide whether the line that is shown is a line of symmetry. Now here's the line if you can't see it. Here's the line that's in your book. And I'll be honest with you, I think a lot of you would, without any doubt, would say, yes, that's a line of symmetry. Because if you were to fold this picture, well, I'm having a hard time drawing a line here. If you were to fold this picture right in half, this side over here would fall directly on this side over here, and you're right for the most part, except look at this peg here sticking out, and look at this peg here sticking out. Do we have to be that picky, Mr. Earhart? Yeah, you do. Yes. If you were to fold this over, this peg would be right down here. It would not fall directly on that peg there, and neither would this one. Okay, now I'm not a musician, so I'm not sure if these are called pegs or what they're called, but hopefully you get the point. So no, that red line in your book is not an example of a line of symmetry. All right, number 22, yes, definitely. Of course, you see the answer right here, but definitely, yes. I mean, here it is. If you were to fold that picture right in half, everything would fall right on top of everything on the other side, so definitely yes. Yep, same thing in 23, definitely. If you were to fold this picture right down this red line right here, look at every single edge. Everything over here would fall directly, exactly on everything over here. So we would definitely say this red line is a line of symmetry. Okay? All right, moving on to the last three. These last three will be interesting. I'm going to grab another drink of water real quick. These last three will be interesting because they're difficult, okay? They want to know how many lines of symmetry can be drawn. Now, I know you've got the answer right here. Just ignore that for a second. Well, if I drew a line, let me get my shape recognizer here. If I were to draw a line from here to here, a straight line, of course, doesn't that cut this thing right in half? Sure it does. How about if I drew a line from here to here? Would that work? I think it would, guys. Should have brought that down here with me. There we go. Sure it would. Definitely. Guess we can't group that together. But anyways, if you were to rotate this thing, of course the red line won't go with it, so it's not going to help any, but anyways, it would definitely cut this in half. And my point is simply this, students. Let me go ahead and rotate this back and then we'll draw some lines. Sometimes it's not easy to see unless you turn your book around and do stuff like that, but this line here would definitely cut the object right in half. This line here would definitely cut the object right in half. That's a line of symmetry. This would cut the object right in half. I know my lines aren't perfect, but you get the idea. This here would cut the object in half. And then so would this one here. It'd be 5 altogether, students. There would be 5. 1, 2. Let's see here. 1, 2, 3, 4. Here's the fifth one right here. right there. So there are 5 different lines of symmetry. Okay? All right. Let's continue on. Number 25. Okay, they're going to state that we have 4 lines of symmetry, and let me show you where these would be. If you were to draw a line here, this would, wow. If you were to draw a line right here, that would definitely cut the object right in half. And if you were to draw a line here, that would cut the object in half. So that's 2. I'll put tally marks, 1, 2, and now watch this. We'll just put the number 2 so far. Now watch this over here. If I were to draw a line from here to here, that would cut it right in half. If you were to fold this picture right on that red line, we would have no problem with that at all. It'd be totally, one side would fall right on the other side, definitely. And then here's the other one, right there. If you were to fold that picture right there on that red line, this side here would fall right on top of this side over here. So that's 2 more lines. So we have a total. We could draw 4 lines of symmetry. 4 lines of symmetry. All right. And number 26, they're saying 2. And let's think this through for a second. Obviously, if I drew a line from here to here, that would cut it in half. And of course, you understand, I'll try to fix this, but it's not super easy to do. So if I were to draw a red line here and then fold this picture right on the red line, this side would fall right on top of this side over here. And if I were to draw a line that ran from here to here, of course a little straighter than that, but if I were to draw a line from top to bottom right there, this side here would fall on top of this side over here. So the most number of lines of symmetry I can draw would be 2. You can try to find some more, but they're just not there. Okay? All right, that is it, guys. I don't feel like the homework was difficult at all, nor was the video hard at all. I hope that you agree with that. Feel free to call or email if you have any questions. I hope that this homework help video has been a help to you.